Okay, 2.6. This is going to take a while here, so you might want to get a drink and settle down here for this one. This is talking about centers of mass and moments. So first of all, we have a whole bunch of terminology we need to get comfortable with. So first of all, we're going to use this X bar. That's going to indicate a balance point, meaning that we have this value. And in this case, we're only talking about one dimension, so just on the x-axis or on an axis. Where is the point that will balance the system, whatever the mass is? And so then we use lowercase m with a sub 1. So m sub 1 is the mass of object number 1. And then we use an x sub 1 to indicate the location of that object. So this information is referring to how much the object weighs and where it is. So we can have an m sub 1, x sub 1, m sub 2, x sub 2, but they go as a group, okay? So first of all, we're going to introduce this idea of moments. And a moment is when you take the mass and multiply it by the distance it is from the center. So in order to find the center, I'm going to show you a two-object example of this. You take the total moment, which is just the multiplication, just the product of each of the masses times its distance from wherever we're talking. All right, you add those all up and then you divide by the total mass, and that will get you this balance point. Okay, so the big picture is that we can find this capital M. So note, lowercase m is total mass of the system. The uppercase m is the moment of the system. So you're going to add up this product, however many there are, and we're going to add them all up. You're going to add up the mass of the whole thing, and then you divide the moment divided by the mass, get you the balance point, okay? And we will look at some examples, a lot of examples actually, in a little bit. Next thing is we're going to now go to a plane. So in this case, we have our objects that are at a x, y coordinate. So in this case, we have x sub 1, y sub 1 is the location on a xy plane of object 1. X sub 2, y sub 2 is the location of object 2, et cetera, et cetera. So in this case, we're going to use these formulas, and this gets tricky, my friends. Be super careful here. To find the moments with respect to x, you're going to find the y coordinates. So you're going to multiply, you're going to sum up all of these moments in regards to y. And then you're going to do the opposite for the moments with regard to y. This is confusing because these flip right here. Then to find the center of mass in a two-dimensional plane, to find the x, you divide by that y to find the x. Because remember, these are x's in here. So now, could they have done a better job of notating this so you don't have to be confused like that? Of course they could. However, the book does it this way, and I didn't want to do something different with you than what was in the book. And the same thing with the y coordinate. It's the moments in regard to x divided by m. And again, we'll see some examples of this in just a minute. So this should be written down. These should be notes when we're doing center of mass in a plane. COM is center of mass. The last, oh no, we're not last, sorry. First of all, I'm going to introduce two new words for you. First is something called a lamina, which basically, it's just a math word for just a sheet. And we consider a lamina to be two-dimensional. Now, it can be curved and have shapes and be wobbly and stuff, but it's still two-dimensional. And then a centroid, the word centroid, refers to the geometric center of an object. So again, we're assuming that it has an equal density everywhere. Then the centroid would be the center of mass, okay? So we're going to learn some formulas right here. So first, the mass of a lamina, the mass function, is equal to the density function. And for our purposes in these examples, we're going to use a uniformly dense material. So these row values will all be 1. So you don't have to worry about these. And we're actually not going to practice with anything that has a different row value, but it could, and that would just go out here. And notice it's outside of the integral. So it would just factor in when you did your final answer. So we're going to go from A to B of whatever the function is. That will get you the mass, that you want the total mass of this object, whatever the sheet is. Then we're going to find the moments with respect to x, and it's this formula here. So from A to B, this is f of x squared divided by 2. And then the y version is not that at all. It's x times f of x. So these, again, write those down somewhere. This is how we find, this is the mass, and these are the moments of a lamina. Then when I want to find the two-dimensional points here, you know this is exactly like we did before, right? The moments with respect to y divided by mass is the x value for the center of mass. Moments with respect to x divided by the mass is the y value, the y center of mass value. So you see that similarity there. And again, we're going to do some examples here in just a moment. Last one is if you have two curves. I want to find the center of mass between two curves. The formula is this: if f of x is the curve above and g of x is the curve below from A to B, and if you have a row value, you'd put that out in front again. Same thing. The mass function is just the above curve minus the below curve, evaluated from A to B. And here we go, 1/2 above curve squared minus below curve squared, evaluated from A to B for the x. And the y is x times the above curve minus the below curve. And remember, you got to have to distribute that x. And notice this part's the same again, right? And you'll see how this works in just a minute. So these, I'm just showing you the formulas here, and then we'll apply them in our next videos.